Okay, we'll talk a little bit more about parts of the electromagnetic spectrum in this video, and a specific part of the specification about this idea of the perfect black body. So you should remember that when things are hot, they are emitting more infrared radiation than they are absorbing. Hot things emit heat radiation, okay? And black surfaces are the best at absorbing heat radiation, infrared wavelengths, and they're also the best at emitting heat radiation. So we already know that a dark surface is both the best emitter as well as the best absorber of heat radiation. So if something was perfectly black, that would mean that it would absorb all of the radiation shining on it and reflect none. So a perfect black body would be the best possible absorber and also the best possible emitter. The color of hot objects is because they are emitting different wavelengths of electromagnetic radiation. And this graph here is showing you two things: that when the temperature increases, so this top curve is 1000 degrees Celsius compared to the lower curve, which is 750. Notice that they both have a shape with a peak in the middle, but the 1000 degrees line has a much higher, much taller peak, and the peak value of wavelength is shifted towards smaller numbers. So the hotter an object is, the more intense every wavelength is that is being given out, and also the peak intensity is at a smaller wavelength than at lower temperatures. Okay, to recap then, specific information about what happens when different waves are absorbed. Radio waves, the lowest energy, longest wavelengths, lowest frequencies, are absorbed, and when they are absorbed by a conductor, an alternating current is induced in that conductor. This explains how radio waves can be used to send information from a transmitter to a receiver, or also in things like Bluetooth, which uses radio wave frequencies. Microwaves strongly absorbed by water, which vibrate, gaining kinetic energy and therefore making food hot. And a property of microwaves that they can also pass through the atmosphere, so we use them to communicate with satellites. Infrared radiation is heat. It makes things get hot. It can burn you and damage your skin. It's also used in things like TV remote controls to carry a digital signal, for example, to change channel on your TV. Ultraviolet is the part of the sun's electromagnetic radiation that gives you a suntan or gives you sunburn if you stay out too long. There is a risk that your skin cells will be damaged, and that could lead to you developing skin cancer. Ultraviolet radiation is also used in sunbeds and in security markings as special pigments. For example, on a £10 note, absorb ultraviolet and then re-radiate visible light so they become visible to the naked eye. Make sure you know the medical applications of X-rays and gamma rays. X-rays for taking photos of broken bones, for example, because they are more strongly absorbed by denser materials, and gamma rays both to treat cancer by killing cells, but also to sterilize medical equipment. We are at the highest energy, lowest wavelength, highest frequency end of the electromagnetic spectrum, and the gamma rays are more likely to cause damage by ionizing your DNA.